performance, ask the database administrator to why don't you create the index for ID plus name. Okay, then it works usually because you create the that table. However, that's not good for overall performance always. The meaning is that the reason is that if you create the one more index, whenever you insert the new data like the lib, you need to change the ID. You need to change the name. You need to change the old index, which requires sorting. So as we have seen the index structure, how to build the B plus 3, B3 index. Whenever we insert the data, we need to get check whether full, in case of full, split, and promote, and so on. So it's really overhead. Also, not always the index is the best choice, as we have seen before. Sometimes the brute force way is faster than using index. Idea is simple. So if the Professor Lee gives the homework to find the definition of 1,000 word, 1,000 keyword, okay? Which way will be faster? For each keyword, check the index, okay? And or search the Google and find the definition. 1,000 case. Instead, read the textbook, then write down. Which one will be faster? You'd better read the textbook, okay? Then understand your textbook, entire textbook, okay? It takes 2 hours. Then you can get the idea overall, and write your definition based on that. Because whenever you are using the index, you need to use additional I/O, require additional I/O. Okay? So the more data you need to access, actually, brute force way, the full table scan or linear search is better. The rule of thumb is if data is 20% selection cardinality, selection ratio, which means if primary key, definitely the key is the unique. So index is better. But the DNO, department number 1, department 2, department 3. So average is 30%. Then full table scan is always better because it's too much overhead to read the index. So at that time you can use the comparative index, but should be careful. So this is a different ways to access the table. And the next one is a join operation. We will see more details today. The join operation. There are how many different ways of join? Actually 4, but we talk about the 3. So nested loop join is a brute force. It's each and every case 2-level join, 2-loop join. Okay. Then single loop join. In case we talk about this is the driving table, outer loop. So in case of full loop, this one. For each this, for each this. So inner table is a driven table. Driven table. So for each everything. This is a nested loop. Single loop is for the driven table we can use index. At that time we don't have to search all of them, just index search. That is a single loop join. And third one is as I introduced just before, sort and merge. And fourth one is hash join. I'm going to give the idea of the hash join. So we can apply the hash function for each driving table. So if you have the 5 hash bucket, so each data will be one of these, right? That's the idea of the hash. Complicate data will be simpler using the hash. Then apply the same hash function for the driven table for each row. Then for this one, like for this. Then search only the same hash bucket. So if we are saying just 20%, 20%, 20%, 20%, 20%, your search area will be only the 20%. This is the idea of the hash function, a hash join. Problem? collision is always a problem, so that's the general thing. What about this? You need to keep the hash bucket in memory. It requires I/O, and what if this table is 1 terabyte? This is 1 terabyte. It will be huge table in the memory. It's a temporary. So that is one of the biggest problem. So there are different ways to address such a problem that I'm skipping, and that I skip, but you can find more information from the textbook. So nested loop join, single loop join, sort merge, and hash. There are some hash. So for the join, we need a buffer space for what? In between. Whenever match it, we need to store the data in somewhere. You'd better use the memory. Okay, then return finally to the user. So that is the buffer space, memory space for the join, matched one. Another one is how many. Not always they are joined. Sometimes it's not matched. How percentage of matched one? Okay, total. Let's say for example, 10, 5. How many total different cases of the join? 50. Out of how many of them are joined? So this is called the join factor. So that is the join selection factor. It will be considered in the query processing layer. Okay? Then another important thing is, so let's say this is an employee, this is a department. Employee in this case, driving table, and the department is the driven table, which means for each employee, we'd like to find, match the department. What about the department is a driving table, and the employee is the driven table. Any difference? We are doing not outer join, okay, inner join. Outer join can be different, okay. Outer join, do you remember the outer join? Left outer join, right outer join, full outer join. Left outer join is we keep the all left hand side, whether or not, doesn't matter, match it. Not matched, no. Okay? But the inner join, which means only matched one will be returned. Any difference? D join on the E join on the D. For example, first the output. There's no difference. You can join this one to this, or this one to this. What we want is just a matched one. So there's no difference in terms of output. But what about the performance? Performance means which one will be faster? Any difference? No difference? First, nested loop join. What is a nested loop join? For each, for every. So, for example, if you have the 10, 5, for 50 times, change 5 and 10. How many times? 10 times, 50 times. Still, it's the same. In case of nested loop join, it's the same, brute force case. Because it's a brute force all every case. What about single loop join? So let me give the example. So we have the extreme case. So it is funny. There was a funny, the reality, it's not reality show, it's kind of the, how can I say, something weird, the TV program in my hometown South Korea. So in South Korea, the military service is compulsory. It's mandatory. So I must serve. When I was when I joined the military, it was 27 months, 28 months around that. Nowadays it's less than 24 months, which means almost 2.5 years I need to stay military camp. Really. So get away from the friend, get away from the, so only the military camp and only 30 days vacation during my military service. So I was there. Then because of that, from time to time, there is a kind of celebrity, mostly celebrity come to the military camp and have a kind of the show. So kind of to enjoy. So mostly you have seen the Vietnam War or the something where the celebrity visit such the camp area and have a show. Sometimes mostly sexy, nice, such a music and like the dance. So like that. The one of the interesting the part of the show is they bring the one parent. Then they wait behind the stage. Okay. Then give only the voice. Then and there are a lot of the soldiers in front of the stage, like 1,000. Okay. Then if you believe this is your parents, come out to the stage. Okay. Then this kind of the usually end with a lot of tears. So cry a lot of things because most of them miss their parents and the family, but only one parents coming and try to. So if you believe, then at that time, so we try to match the parent and the soldier. So one way is if you check the one by one, okay, like 1,000, then whether this is your parent or not. How many times? 1,000 times. It will take like 2 hours. Instead, bring the parents to the stage and call their child name, son's name. Only son is mandatory. Woman, female is not the responsible. There is no responsibility for this. So that call their son's name. How many times? Just one time. Which one will be faster? Output is the same, but performance definitely. Calling the son's name is faster. That's the exactly same idea as this one. Depending on the size of driving table and driven table, it's a huge difference. That's a common mistake. The database sometimes knows which one is bigger. Catalog table. So if you have such a statistic, Query Optimizer knows which one is a driving table, which one will be driven table automatically. Problem, not always the database administrator are very diligent to update the data. Instead, ignore such a updating. So then, what happened? So, Query Optimizer use all the information or sometimes weird information like no data inside. Then, one of the common approach to decide the driving table or order of the join is A, B, C. They are using last one as the driving table. Then join with B and join with A in case data is not up to date. Okay. Then if this one is so big, it will take a longer time. So you can put, by changing the order, output is not changing. By changing the just order, you can get the fast response, really. So this is the idea of the, which one? Choice of inner versus outer, which means order of the join. Okay, these are the factors you need to consider in the join operation. Okay. Then, question, I'm going to skip this part. So we will see the real example of how to calculate the cost later after I go through this one. Okay. Then there are a lot of things in addition to we talk about the selection and the join, but that's not the only operation that we have learned. There are like the union, intersection, the set operation, and the Cartesian product, and a lot. But the most important part is the selection and join. but the other. So I think that you can, if needed, you can study by yourself. Okay. Then also another important part of the query process is how to speed up such the aggregate operation because of sorting. Okay. So this is another one you need to consider in the sorting. Okay. And also outer join. Outer join, we need to keep all the data for the driving table or driven table. Left outer join, right outer join, for outer join. Okay. Then many of them actually try to modify the join algorithm. Okay. But I'm going to skip that part. Pipelining is, what is a pipeline operation in computer? Which means when we have the two operation or two tasks or whatever, two of them, always we have input and output, and also input and output. One of module, their output will be automatically input of the another module. In case of two command, we can, instead of running two commands separately, then if they are connected, we need to save the output of the first command, then feed on the next command. So you need I/O, you need extra space, so it takes a longer time. Instead, we just communicate directly. Then output of first one will be input of next one. That is called the pipeline. So pipeline is a very, very useful the operation in any computer system. For example, in the Unix, if you are taking the Unix, the pipeline is this one, right? For example, ls minus al pipe wc. This is a word count. How many word output of this one? You don't have to save this one, then count. Instead, output of ls minus al will be input of word count. This is called the streaming programming or pipelining. Then we can use the pipelining for query optimization. How? We have number of relational algebra operation. So one operation will be output of one operation will be input of the next one. Then we can save the storage in between. We don't have to save just it. So this is one of the interesting approach to improve the performance of the database query, especially join, because one output of one table will be input of the next table. So we can use the pipeline approach. So pipeline, we can use the pipeline approach for the join. Sometimes it's called the stream-based processing. Okay, then I'd like to explain a little bit more for the heuristic approach. So heuristic approach is, for example, think about when you travel to the several cities, okay? Sometimes some of them are obvious case, like are you going to take the private jet? Even though there exists a private jet or helicopter, chopper, to travel to the Manhattan, most of the case will not be considered. It's obviously it's a rule out. I know some of you are super rich, so you may use the private jet, but mostly rule out. When you search the Expedia.com or Google Trip, you don't consider the private jet. Okay? So, however, when we count number of different cases for this query, how many different cases? 1,000 easily, 2,000. That include all the cases, all of them. However, if we rule out in advance some of non-obvious, so obviously we don't need, okay? Then it will be narrowed down. The case is not 3,000. If we rule out some of the cases in advance, only 100. Okay? Then consider only 100 different cases. Because one of the problem of the cost-based optimizer, goal of cost-based optimizer is to reduce the time, right? To find the fast route. Problem is, it takes a long time to calculate the cost. Doesn't make sense, right? Our goal is to reduce the time, but because of that, it takes longer time. It doesn't make sense. That's one of the problem of the cost-based optimization. So heuristic approach is we try to apply some of the obvious, non-obvious case to rule out as soon as possible. That is called the heuristic approach. What kind of heuristic rule can be eliminated? Can eliminate? What kind of heuristic approach you can imagine? One example is you select the data. What is a relational algebra operation? Relational algebra expression. Selection ID from employee, then project name and result 1. What about this? Result 2. Any difference between result 1 and result 2? No difference, right? It's the same thing. You do a return, only name of ID is equal to 111. Okay? Then, performance, which one will be faster? Number 1, R1. Number 2, R2. Number 3, same. Number 4, I don't want to think. Number 1? Why?
You select the ID first.
Then it is project.
Right.
ID first.
And then take out that name according to the ID. But in the second, it will take all the names and then take out the ID.
But then, we have only one data, one row. In the database, I have only one row, that is lead, 111.
3.
Why? For example, how many columns? In the employee, 10 columns. You need to keep all the columns data, right? In the where? Memory. Then, check the name. However, this one, only name and ID. Okay? How many data? Only one data. Then check whether ID is equal to 111. IO, which one has more IO? This one has more IO. Okay? So which means, depending on the situation, if you believe so, you can remove the, like for example, address, social security number, and all the other information. You don't need this one. You don't have to keep during the processing. If you do not use the stuff while you are traveling, you can throw away as soon as possible, right? Because it can reduce the I/O. So heuristic approach is always process earlier, as soon as possible, any operation that can remove the data, rule out the data. Okay? So if you take out any data in advance, then the query will be faster. That is the idea of the heuristic approach. For example, let me give the example. This is the query that you learn. For every project, whatever, I explained the very easy way to make the relational algebra expression. Decide table first, then join. Find the join condition. That is the relational algebra. This one. 3 table join, or even Cartesian product. Then apply join condition. That is this sequence. We are joining 3 tables here. Then, as we learned before, there's this is a query tree. Query tree shows how the query optimize, query process access the data. For example, here, first the project, okay, and check the Stafford. It's a join condition. Not join condition. This is the selection condition. Okay, then join with the department, the number, and join with the employee. Then finally we can get this data. Another approach is as I suggest, Cartesian product 3 table and apply condition. Right? Output same. So for example, in your midterm exam, if you answered this way, only one student did. One student answered this way, get the full credit. I think only one student. Is there anyone here? One student answered this way. But it's a correct answer. Output is not different. So you can use only Cartesian product and condition for your midterm exam, but not the real project. Okay? Your project manager will kill you if you use this way. It doesn't consider performance. Why? You need to keep all the combination in the memory. And all the combination in the memory. For example, if project 10 department, how many? 100. If you have the 100 employees, so easily 10,000 combination in the memory. Then it will take a longer time. Okay? Instead, if we rule out only take the Stafford, then the join only department that join with the Stafford, and then the only employee who are in this department. Then how many row in the memory? It's a very few. Comparing to this one, much faster. So then, which means in the heuristic approach, if we lower down the operation that rule out, that eliminate the data, we process as soon as possible. This is the idea of a heuristic approach in the query optimization. So, for example, so this is the one of the solution. It's a very simple solution of the query, but first we try to apply the B-day, okay, for the employee. No. So apply any selection condition to the table, like this one. Then project is the lower selectivity. In other words, remove a lot of data, the first stage. Then only few of them will be joined into work sort. And the memory is a small amount. Then so on. But still it's not perfect. So like why don't we apply the join condition as early as possible? Then the employee. And also, for example, the project P number. We don't need all the information about the project. Only P number is used. So apply the project relational algebra operation earlier, as early as possible. So this is called the heuristic approach. Heuristic rule is like this one. However, in short, you can apply any operation that eliminate, that rule out the data, then apply that as soon as possible. Then the query optimizer can actually don't have to calculate all the cases. After you apply the heuristic, you can apply the cost-based function as less as possible. So that is a heuristic approach. Okay. Then final output is the query execution plan. There are a lot of things you need to consider for the cost. However, we will consider only one. Storage cost, I/O, number of I/O. The commercial DBMS, they do not consider the other access cost to secondary storage. Storage cost means it's a memory storage. Okay, the secondary storage. When we are talking about just storage or primary storage, it means it's a memory. It's cheap, much cheaper than the secondary storage, but slightly. So in this case, we ignore the other. Okay. Then we have seen all of this. I'm going to skip this part. do not memorize, but you need such a function in your exam. But you are able, if you understand what is the linear search, y is b over 2. If you understand the algorithm, then you can easily make such a course function. Like the binary search is the same thing, and the most used one is a b plus 3. But you should be careful. Equality and inequality are different. Equality is x plus s. Then this, in case of primary case, s is 1, right? Selectivity 1. So it will be x plus 1. That you know. That I explained in during the index. But in case of the Rayleigh query, you need to count the number of blocks in the leaf node. Conjunctive we did. Okay, so last class we talked about this one. Then I'm going to skip that. Finally, the join operation. Yes, join. For the join, so we are going to join this one and this one. So you need to count number of blocks driving table, right? That's the I/O. You cannot avoid that. You need, and the number of I/O on the right-hand side. Then problem is, depending on how to join the two tables, number of I/O in between are different. So that is called based on the join selectivity. Join selectivity is the ratio that I explained here. How many total cases? Denominator. Numerator is the joined tuple, joined case. How many of them are joined? So it's a R is a joined case. The number of the tuple over R times S. That is a joint selectivity. Then how to calculate the number of I/O? It's not record. It's a block. Okay. So number of I said R. Oh, this is the number of record, the ratio, because it's a ratio. It's not the I/O, it's a ratio. So number of times of the driving table, number of times the S. It's the I times S, the denominator. This one is the number of the joined case. Okay. So joint selectivity always the less than, equal or less than 1, because it's a ratio, and bigger than 0 because it's a. Then finally, size of the result is the joint selectivity is this, and times R and times S. Then that is how many results will be returned. So, for example, in case of a nested roof joint, how many block left hand side? How many block right hand side? Okay, so P of R. How many left hand side? Driving table. And this one is for each. For each, you need to read all the data, and that is the B times BS. Okay? First, you need to read the left-hand side. That is the B of R, driving table. Then, for every case, this one, how many times? For each, you need to read all of this. For each, read all of this. So, B of R times B of S. Plus, how many of them are joined here? So joint selectivity is the joint selectivity times I times S. That's this one. But should be number of block. So divided by what?